All right, so today we're going to learn how to prove two parts in a triangle are congruent. Okay, so we're basically doing the same thing we did in class on Wednesday, but we're adding one extra step. All right, so for example, in this problem, it says triangle ABC is congruent to triangle JKL. What else do you know? Well, we know segment AB is going to be congruent to segment JK if we know the two triangles are congruent. We also know side BC would be congruent to side KL. Right? We basically know all their parts are congruent. Once you know that they're the same, the two triangles are congruent, you know every one of their parts is congruent. So side AC is congruent to side JL. We also know angle A would be congruent to angle J. We know angle B is congruent to angle K. And we know that angle C is congruent to angle L. Okay, so once you already know that two triangles are congruent, you know all of their corresponding parts are congruent. So in this example, it doesn't tell us the two triangles are congruent. Instead, it tells us that these parts are congruent. Specifically, it tells us that segment MN is congruent to segment RS. It tells us segment NL is congruent to segment ST. And it tells us segment LM is congruent to segment TR. So since I know those three sides are congruent, I can also say that triangle MNL is congruent to triangle RST using the side theorem. Now, because those two triangles are congruent now, because I first proven that those two triangles are congruent, now I can say any of their parts that correspond are also congruent. So I could say, for example, angle M is congruent to angle R. This is using the whole CPCTC. Corresponding parts of congruent triangles are congruent. I could also say that angle N is congruent to angle S using CPCTC. I could also say that angle L is congruent to angle T using CPCTC. So you first always have to prove that the two triangles are congruent, and then once you have that, then you can say their corresponding parts are congruent. All right, so let's give it a try and a proof. So you can see what's given to you. You can see we have angle Q is congruent to angle S. Like I've emphasized so many times, you have to mark up your picture. Otherwise, doing proofs is pretty much impossible. So I'm marking up my picture with an arc at angle Q and angle S to show that those two are congruent. We are also told that angle RTQ, so RTQ, which would be this angle, I'm going to put two arcs so I can tell the difference, is congruent to angle RTS. All right, so I've used up everything in my given. All right, that's always what you want to do. Use up everything in your given. Once you're done with the given, then we have to look at our picture. And if I look very closely, hopefully we all notice reflexive property, right? RT is congruent to RT. So that's going to be step 2. Okay, so now I have 3 things. I've got an angle, I've got another angle, and I have a side. Now you need to look at your picture to make sure it's not angle, side, angle, and it's actually angle, angle, side, which if I look at my picture, I've got an angle, and a side, and that is for both triangles, angle, angle, side. So now I can prove that the two triangles are congruent using angle, angle, side. Now it's super, super important that when you go to write in the triangle congruence theorem, saying this triangle is congruent to that triangle, that you make sure that everything corresponds. So what I mean by that is that if I put Q first, I have to put S first over here because Q and S both are congruent to each other. If I put T second, I have to put T second in the other triangle because T at angle T in both triangles, they're congruent. And then R is the same in both as well. So I can say that the triangle on the left, triangle QTR, is congruent to the triangle on the right, triangle STR, using angle, angle, side. Now, I need to point something out to you. Before, when we did proofs, it was always just proving two triangles are congruent, and we would stop when it looked like this, right? We'd be like, oh, triangle congruence theorem, we're done. This is different. Look up here what we're trying to prove. It does not say prove two triangles are congruent. Instead, it says prove that segment QT is congruent to segment ST. So because we've already proven that the two triangles themselves are congruent, all of their corresponding parts are now congruent. Specifically, side QT and side ST. So now I can go over here and be like, oh, well, since these two triangles are congruent, these two segments are going to be congruent to each other. And that's called CPCTC, which stands for corresponding parts of congruent triangles are congruent. You will need to know what that means, so make sure you study that. All right, so that's how we would do this proof. You always prove the two triangles are congruent first, and then once you've done that, you can prove their corresponding parts are congruent. Okay, so let's try another one. Again, we start by writing down our given, right? So we are told that segment AB is congruent to segment CB. Right? I just used that part in my given. We are also told that segment AD is congruent to segment CD. So on my picture, I'm going to mark off AD and CD with 2 tick marks so I can tell the difference between what pair are congruent. All right, so even though this says to prove these two angles are congruent, I have to first prove the two triangles are congruent. So I'm stuck, so I look at the picture. Hopefully we all see, oh, reflexive property again. So I use that. So step 2 is going to be line segment DB is congruent to line segment DB. All right, now I have 3 things, right? I have a side, another side, and a third side. So I can prove that the two triangles are congruent using side, 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 right? All 3 sides and both triangles are congruent to each other. Again, when I write out my congruence statement, I have to make sure that they're lined up correctly. So if I look at this picture, A corresponds with C. B corresponds with B, and D corresponds with D. So I'm saying that triangle ABD is congruent to triangle CBD using side, side, side. So now that I've proven the two triangles are congruent, all of the remaining parts are congruent. So for example, this angle right here would be congruent to this one. This angle right here, C, would be congruent to A. And this one over here would be congruent to this one as well. All right, so we only care about proving A is congruent to C. So I finished my proof with step 4, stating that angle A is congruent to angle C using CPCTC. Again, that stands for corresponding parts of congruent triangles are congruent. All right, so here is our last one. All right, so let's set it up just like we did before. We are given that angle 1 is congruent to angle 2. So angle 1, I'm marking it off in my picture, is congruent to angle 2. we are also told that angle 3 is congruent to angle 4. So I'm marking it off in my picture with 2 arcs at angle 3 and angle 4. And again, a reason given. All right. So if I look at what I'm actually given, this one's a trickier one. But if you're looking here, angle 2 is actually this angle, and angle 1 is this angle. If you look at angle 3 is this angle, and angle 4 is this angle. So we're actually going to start this proof by dealing with the 2 bigger triangles. And so to help us with this, I'm actually going to have us draw these out. So I've got the triangle on the top, A, D, C, where I had that angle 2 and this angle 4 marked off. And then I have the triangle on the bottom. And I just didn't draw them connected here. So I've got B, C, A. Again, I've got the 2 and the 1 marked off. So if I were to connect them, hopefully you guys would all notice that we have the reflexive property here, right? CA is going to be congruent to CA. That's step 2. Now, when I do that, I can now prove that those 2 big triangles are congruent using angle, side, angle, right? The side is marked off between the 2 angles we have. And you can see we had 2 angles and a side in our proof. So we are all taken care of. So we're using angle, side, angle. Even though it does not say angle, side, angle in that order, it still in our picture shows angle, side, angle. All right, so I have to name these 2 triangles and state that they're congruent. So C corresponds with C, B corresponds with D, and A corresponds with A, using angle, side, angle. Now you're going to go, Mrs. Ethorn, you did not prove the correct triangles. If we actually look at this, BCE is this little tiny triangle, and we just proved this big triangle was congruent to the other big triangle. DC is also the small one. So we have more work to do. So if we look at the actual little triangles that we're trying to prove are congruent, it's these 2. So I'm going to redraw just that part. And so far with those little triangles, I only have these 2 angles right here in my proof marked off as congruent. Right, that was this step right here. Angle 1 is congruent to angle 2. So we already have that in our proof from our given right here. Now, we can use the reflexive property. So we can state that segment CE is congruent to itself. But I still can't quite prove that those 2 smaller triangles in green are going to be congruent. So here's the trick with these. If we know that these 2 bigger triangles are congruent, we can use a part from these 2 to say that these are congruent. So you have to ask yourself, what side or angle is in the big triangle and also in the small triangle? So hopefully we can figure out that this side CD is the same in both the big and the small. Likewise, CB is the same in both of them. So since I know these 2 triangles are congruent, I can say these 2 parts are congruent using CPCTC. So I could say that side CD is congruent to side CB using CPCTC. So if I add that to this picture where they're small, now we can prove the 2 triangles, the 2 small ones are congruent. So triangle BCE would be congruent to triangle DCE. And if you look at your picture, I've got side, angle, side. Side, angle, side. And we're done. right, go ahead and give this a try with the homework.